Hello, guys. Just wanted to start you off with talking about a couple acts that you need to know. The first is the Clean Water Act from 1972. The Clean Water Act supported the protection and propagation of fish, shellfish, and wildlife and recreation in and on the water by maintaining and sometimes restoring the chemical, physical, biological properties of surface water. So the Clean Water Act just regulates contaminants of all surface water for wildlife and then also for our recreation. So that's what sets it apart from Safe Drinking Water Act. For the Clean Water Act, we might not necessarily be drinking that water, but it impacts the wildlife in the water and then also our recreation in that water. And the Clean Water Act looks at criteria pollutants, which include 167 chemicals and substances. The majority of those are toxic, but they could also be nutrients or pH or hardness. The Safe Drinking Water Act from 1974 looks specifically at drinking water standards. And it actually sets the national standards for safe drinking water. And these national standards for safe drinking water are designated as maximum contaminant levels. To give you an idea of what these maximum contaminant levels would be, like arsenic is going to be 10 micrograms per liter, which is pretty low. So the Safe Drinking Water Act sets much more rigorous standards for the contaminant levels than the Clean Water Act because we're actually taking it in. Criteria for continuous concentration is the highest sustained concentration beyond which undesirable impacts may be expected. So if you go back to thinking about hazardous waste and toxicity, we talk about dose being concentration times the amount of time. Criteria continuous concentration looks at how that concentration is sustained. Right? Whereas maximum contaminant levels is just a single concentration, the highest single concentration where you might get some impacts. Right? So this is a single concentration, this is concentration over time. Total maximum daily load is just a federal program that is evaluating all sorts of pollution that enter a body of water, especially non-point sources. So they look at how well the body of water is able to assimilate those pollutants. So now I'd like to talk a little bit more specifically about wastewater treatment and management, and so what wastewater is and then how we treat it. So raw wastewater is made up of 4 main types of ingredients. And when raw wastewater comes into a treatment plant, it's 1,000 parts water for every 1 part waste. Okay, so raw wastewater output, you get about 150 to 200 gallons of wastewater per person per day. Okay. And then stormwater is going to dilute that raw wastewater even more. So not only is the stuff from your toilets and sinks and stuff going into and showers going into this wastewater plant, but it's also mixing with stormwater, right? So it dilutes the wastewater quite a bit. So there's 4 categories of pollutants that can end up in wastewater. There's debris and grit. So debris could include like rags, plastic bags, stuff that can wash down drains from stormwater. And then the grit would be like sand and gravel. Particulate organic material is fecal matter, so poop, right? And also can be food waste. So if you have a garbage disposal in your home, the food matter that goes down that garbage disposal ends up in wastewater as particulate organic material. Could also be toilet paper. Toilet paper is going to be organic material. It's going to dissolve a little bit, so it'll be more particulate. For colloidal and dissolved organic material, This includes really fine particles of organic material. So it could be like really more dissolved poop. And then also urine, bacteria, soaps, detergents, cleaning agents. So when we often think about wastewater, we think about stuff that's just going down our toilets, but it's also stuff that goes down our sinks, and like laundry and showers. So it can be those soaps and detergents and cleaning agents too, and that's included in this colloidal and dissolved organic material. The last bit is dissolved inorganic material. So remember that organic material includes carbon-based stuff. Inorganic is non-carbon-based stuff. So dissolved inorganic material is going to be things like nitrogen, phosphorus, and other nutrients. So if fertilizer ends up in the stormwater drain that contains a lot of nitrogen and phosphorus, it would be included in dissolved inorganic material. Right? You can also get some other stuff too, like heavy metals, toxic compounds, pesticides, if we're pouring out things. So when you treat wastewater, when the wastewater comes into this plant, there's two kind of stages. The first is primary treatment, two main stages. First is primary treatment, and then we'll go into secondary treatment. So the primary treatment is mainly to get rid of the chunky stuff, right? So you want to get rid of the debris and grit. So the first part of this primary treatment is you just send the raw sewage through a bar screen, some kind of screen, and then the debris like plastic bags, sticks, and stuff like that is going to settle out on top of this bar screen, and it can get removed and then sent to a landfill, and everything else that's smaller is going to go through the bar screen. Okay, so the bar screen gets rid of a lot of the debris. Debris includes like bags, sticks, etc. After the bar screen, you let the wastewater sit in this grit chamber. Remember that grit is going to be that sand and gravel type stuff. So that sand and gravel that made it through the bar screen is kind of heavy, so it's just going to settle to the bottom of this grit chamber. Then you can remove that settled out grit and also send it to the landfill. Some of the organic material that's in wastewater can be like fats and stuff. So the next step is this primary clarifier, and in that you get fats and oils that will float to the top of the primary clarifier. Organic material is going to settle at the bottom, and then that organic material that is settling out in the primary clarifier, it's thought of as being raw sludge, which is kind of a fun word to say. Right? So raw sludge is all removed material from this primary clarifier, right? And it includes some of that like chunkier organic matter. So the second step in treating wastewater is more of a biological treatment. So the primary treatment was kind of like a physical separation, where this secondary treatment is going to be a biological treatment. And it's a biological treatment because it's using organisms, it's using natural decomposers to break down waste, right? So organisms will feed on this organic material, right? You can see you're getting rid of this colloidal and dissolved organic matter removal now. They're going to feed on that organic material, and they're going to break it down into CO2, mineral nutrients, and water. And these decomposers are going to do that in the best way by using oxygen. So to do this whole secondary treatment thing, you essentially add decomposers and you add oxygen, and they break down the organic material for you. There's two potential options for this. There's this trickling filter system or activated sludge system. So with the trickling filter system, you have this bed of rocks, and in that bed of rocks, you've got a bunch of different bacteria and other decomposers. You trickle the wastewater onto the rock bed, and as it goes through the rock bed, it's going to become oxygenated, right? So you have lots of oxygen entering the wastewater, and that provides the oxygen that those decomposers need to break down the waste. This activated sludge system, the activated sludge is decomposers. So you add decomposers to the tank, and then you bubble it vigorously with oxygen. That allows the decomposers to break down the waste in the presence of oxygen, which makes them much more efficient. Right? So either way, if you do trickling filter, if you do activated sludge, after the decomposers break everything down, it ends up in this secondary clarifier. And in that secondary clarifier, you just let the organisms themselves, the decomposers, settle out to the bottom of the tank, and then you can, and remember those decomposers are called activated sludge, and then you can remove those organisms, that activated sludge, and pump them back into the beginning of the system. This one, activated sludge versus trickling filter, this one is going to be more common. Right, it's much more efficient, much more common to use this than to use the trickling filter. And then, so the organisms and the wastewater end up in this secondary clarifier. The organisms kind of clump together, and they're going to settle out, and you're going to be left with this water where all the waste has been broken down. So now you're just left with CO2 and maybe some mineral nutrients. So at this point, at the end of the secondary clarifier, once the water is pumped out of the secondary clarifier, at this point, 90% of the organic material has been removed. So not quite done yet. What we still have, if you remember from what I just said, 90% of the organic material has been moved, but we still have some nutrients in there. And now we need to talk a little bit about how we actually remove those nutrients, right? Because if we go back to water pollution, if we have nitrogen and phosphorus in our wastewater, and then that wastewater, after it's treated, gets pumped back into the surface water, that nitrogen and phosphorus can lead to algae blooms, which causes eutrophication. So we need to get rid of the excess nutrients that were not causing this eutrophication problem. So there's a couple, nitrogen and phosphorus are removed in this biological nutrient removal process, right? And the way that nitrogen is removed is different from the way phosphorus is removed. So with the nitrogen cycle, right, bacteria are capable of doing this whole denitrification thing, where they can convert nitrogen back into nitrogen gas, right? So the wastewater has like ammonia in it, right? So what they need to do is they need to convert this ammonia back into nitrogen gas, where and then that nitrogen gas is just going to be absorbed by the atmosphere. Now, our atmosphere is mostly nitrogen, so not a huge deal for nitrogen gas to just enter the atmosphere. So what's kind of neat about this is that if you just put bacteria in there, right, and you create an anaerobic environment, those bacteria will do this whole denitrification thing. So the nitrogen removal is done without oxygen. You can see up here anaerobic, anoxic. What that means is that there's no oxygen there. So when bacteria are in a zero oxygen or low oxygen water, right, they will do denitrification, which converts ammonia into nitrogen gas, right? Then that nitrogen gas just gets released. Right? So these first two zones are the removal of nitrogen in low or no oxygen. Then you can see this zone 3 is oxygen rich. And when you have an environment that's rich in oxygen, but you starve the bacteria, so you remove all of their food, the bacteria will actually take up phosphate. Right? So anaerobic, low oxygen, no oxygen, you do denitrification, that removes the nitrogen part. And then when you want to remove the phosphorus, you bubble oxygen into the tank in this zone, right? So you make it oxygen rich, but you starve the bacteria so that they will uptake phosphorus. Right? So then that removes nitrogen and phosphorus from the wastewater. So at this point, we've removed the chunky stuff, all the chunky organic material, the debris and grit, and then we've removed that dissolved organic material in the secondary treatment. And then we've removed the nutrients in the biological nutrient removal. Okay, so primary treatment, as a reminder, is chunky stuff, bigger organic matter, debris and grit. The secondary treatment is dissolved organic material and colloidal material. And then you remove nutrients in biological nutrient removal. But we still have a potential pollutant in this wastewater, and that's pathogens. Right? Pathogens can make it all the way through the wastewater treatment up to this point. So, in order to remove those pathogens, right, disease-causing organisms, we have to do this final clarification and disinfection. Right? So disinfection will kill off the pathogens. And there's a few different ways to do this whole disinfection thing. The most effective and inexpensive disinfecting agent is just going to be chlorine gas. Right, so chlorine gas, if you bubble it through the water, that's going to remove all the pathogens, and it's pretty cheap to do that. So that's probably the most common way to do it. There are a couple other mechanisms, right? There's Clorox, which is a little bit safer than chlorine. So actually, Clorox, sodium hypochlorite, since it's safer than chlorine, it is more common, right? Chlorine gas is less expensive, but Clorox is safer, so they tend to use that more often. Another option is to use ozone gas. So ozone is O3 instead of O2. And you can use ozone gas to disinfect. Let me get rid of this. But it's pretty expensive to do that, and it's kind of unstable too, so not super ideal. Another way of doing it is using ultraviolet lights, like in this picture right here. So they're using ultraviolet lights to disinfect. So after this treatment, right, at this point, after this final clarification and disinfection, you're done with the wastewater treatment. And at this point, it's lower organic and nutrient content than many bodies of water that it's discharged into. Right, so the BOD, biochemical oxygen demand, is going to be just 10 to 20 parts per million when it was 200 for the incoming sewage. So, as a reminder, we got primary treatment, secondary treatment, biological nutrient removal, and then this final clarification and disinfection. Right, and then knowing what kind of pollutant is removed at each point. So, if you remember going back, right, you had all this sludge, right? Remember, if you had this raw sludge that got taken out of the primary treatment, and then, it says raw sludge removed for further treatment. So what happens to that raw sludge? We're going to kind of talk about that now. All right, so there's a few different ways to do this, to take care of this raw sludge. So this raw sludge is any particulate organic matter that has settled out or floats to the surface in primary treatment. And raw sludge is actually a biologically hazardous material. Right? There's a couple ways to take care of it. One way is using anaerobic digestion. So this is where you use decomposers again. So you use bacteria, and those bacteria will feed on the sludge and anaerobic, so in the absence of oxygen. So you'll get these big airtight tanks called sludge digesters, which is kind of a neat term, that have these bacteria in them, and then you put the sludge in, and the bacteria in the tank feed on the sludge with no oxygen, and the end products are just going to be methane, CO2, and water. Right? That methane is really flammable, but what's neat is you can just then use the methane as fuel, and you can actually use it to heat the sludge digester. Right? At the end of the whole sludge digestion process, you get the remains are that you get this treated sludge or biosolids, which is pretty stable, right? And it's makes like a nutrient-rich material when it's suspended in water. So the pathogens have been largely eliminated, so you can actually use biosolids for fertilizer. Use this treated raw sludge or treated sludge. So that's one option. Another option is to do pasteurization. So this is where you take that raw sludge, you remove the water, you evaporate the water out, and then you have this like sludge cake, and you put that sludge cake through ovens that heats the sludge enough that the pathogens will be killed. And what you end up with, because the pathogens are a really dangerous part of this, right, for us, what you end up with is these dry, odorless pellets like this, right, that you can then use for fertilizer. One problem with this is that heavy metals can be left behind. The last option is composting. Right, so this is this picture here. So composting, you can take raw sludge, you can mix it with wood chips, and then you put it in these long, narrow piles, and this big machine here called a windrow is going to turn that over so oxygen gets added in, and then bacteria and decomposers in the compost will actually break down the organic material. Right, so a few different options there. Now, if you're outside of the municipal system, the municipal wastewater system, your wastewater might not go to the wastewater treatment plant. You might have an alternative system. So one alternative system is to have a septic system, right? So for septic systems, right, you got your septic tank here, then you've got your leach field here, right? You got your household wastewater coming in. So with a septic system, that wastewater gets stored in this septic tank, and in that septic tank, you have particulate organic matter settling to the bottom, right? So you can think of the tank itself, the septic tank, is just like a primary clarifier, right, where all of that particulate organic matter settles to the bottom. You don't really have a big problem with debris and grit with septic tanks because you're not having stormwater mixing in. It's just this household wastewater. So all of the chunkier organic matter settles to the bottom, and then the water with the dissolved organic matter and nutrients will actually get sent over here through this pipe, and it gets sprinkled along this, or pumped into this leaching field, right, which is usually gravel or crushed stone. And that dissolved organic material, the water with the dissolved organic material, will percolate, like kind of wash through that soil and crushed stone and gravel, and the bacteria that are living in the leach field will digest all that organic material. This septic tank also has bacteria in it that are digesting some of that stuff that has settled out. But you do get accumulations over time. So that's why if you have a septic tank, you have to get it pumped every once in a while. So in order to maintain this system, you have to be careful of what you dump down the drain, right? Because some stuff can clog the tank, or it can kill bacteria that are in the system. You want the bacteria there because they're breaking down the waste. So you don't want to. So you need to inspect it regularly, and you need to pump it regularly. Oftentimes, if you can have your garbage disposal go into this septic tank, but if you do, you're going to have to pump it a lot more frequently. And then you obviously don't want heavy equipment on this leach field because that would destroy it. Another option is to use composting toilets, which is actually what we are going to get in the new science building. Right, so the toilet connects to a little composting reactor, right? So you're receiving solid waste in this composting reactor, right? And you have this little exhaust system here, which allows for ventilation because you want an aerobic breakdown in the presence of oxygen, right? And yeah, you want to make sure that it's well aerated and able to break down, and then the end product of this compost has to be buried or removed somehow. And I put this picture in here because this is actually where Brian and I got married, and all these toilets back here are composting toilets. All right, and then we already talked about water treatment. All right, so that is it for wastewater treatment.